Hello guys, and welcome back to another class of our course about the complete introduction to quantum computing. So in today's class we are still going to talk about quantum computing algorithms, and we are going to talk about the quantum walk algorithm. So basically we are going to talk about this algorithm, and then after we are not going to talk about the different algorithms in this type of algorithm. We are going to talk about a type of problem that this algorithm will actually solve. So you'll see it's pretty interesting. So let's start. Alright, so basically what exactly is the quantum walk algorithm? So basically the quantum walk algorithm, how we can see it is, well, at first it's the quantum version of the classical random walk. So for those who are not sure what a random walk is, it's a mathematical concept that can also be called a random process that is used to describe, let's say, a certain path that contains a certain succession of random steps. So basically the main difference between the classical and the classical random walk and the quantum random walk is the element that allows the randomness. So what I'm trying to say by that, so basically in quantum walk, the randomness can happen by the collapse of the waves, the wave functions, the quantum superposition of states, and the non-random reversible unitary evolution. So basically, another thing that for the first part, for the second part, basically the quantum walk admits that formulation in continuous and discrete time. So basically it will admit formulation in continuous and discrete times. And what you guys need to understand here, basically what exactly does this mean? So the two elements right here that are continuous and discrete times are alternative frameworks that are used to model variables that evolve over time. So basically this is for the quantum walk algorithm. And a problem that it helps us to solve, well, basically this problem can be solved by different ways, but it can also be solved in a quantum way. So basically it's called the element distinctness problem. So what exactly it is? So it's also known as the element uniqueness problem. So the element distinctness problem is the problem of the determination of the distinction of elements. So in other words, if elements from a certain list are distinct, yes or no. So this type of problem can be solved in many ways. So if we're talking about classical ways that this problem can be solved, so for example, we can use randomized algorithm, or we can use decision trees, for example. So basically, what exactly this problem can be? So let's say we have a list and we are trying to find the distinctions in this list, and basically this would be this type of problem. So it's possible to also solve this problem in a quantic way, and with the use of the quantum walk algorithm, it's possible to solve it. So basically there are other algorithms that can solve this type of problem. But basically what's cool with solving it with the quantum algorithms is that first of all it will take way less time, and second of all, there are plenty of other advantages, but the most important one is that it takes way less time. So time is a really important factor, and it requires also less variables and less calculations, and the calculation time or process will be less not less complicated, but less heavy, we can say it this way, than the use of classical models, for example classical algorithms or other classical ways to solve this type of problem. So I hope you guys understand what exactly is the quantum walk and what type of problem it helps us solve in this case. So that's it for this class, guys, and see you all in our next class, where we are going to start to talk about Microsoft Q and other different tools that you can use to be able to work with quantum computing.